Hey there, everyone. We're going to come together today to talk about graphing linear equations. Now, what you're going to see today is that this takes everything we've learned about slope, as well as the slope-intercept form equation, and brings it together so that way we can work backwards from what we have been doing. In previous lessons, you would have learned about slope. That slope is rise over run, and it's really a rate, the rate at which our line increases or decreases, climbs or drops. And you would have also hopefully taken a look at the slope-intercept form. Slope-intercept form is, again, the typical linear equation that we use when modeling a line. That is y equals mx plus b. And in those two lessons, what we were doing was most of the time, or all the time, we were given a graph with a line already on it. So we were already given a graph line, and we moved from that to get slope and y-intercept. We pulled that information off, and we wrote the equation of a line. Now we're trying to do the opposite. Now we're going to have all of the information uphand, so that way we can graph the line. So we're going in the opposite direction. And really, the nice thing about this today is that we have these nice, easy steps up here that really kind of outline the process that we're going to take. Remember, whenever you see this, whenever it says graph each equation using the slope-intercept method, that is the goal. That is the intended outcome. We are trying to graph or model the line. So, first things first, we'll write the equation in slope-intercept form. And I know what you're thinking. What do you mean write the equation in slope-intercept form? Most of the time it will be written in slope-intercept form, but sometimes it won't be. There is actually another linear equation that we haven't looked at called standard form. Now, we won't see that today. We're mostly focusing in on the slope-intercept form. So step 1 may not be something we even have to worry about. Step 2, on the other hand, is to graph the y-intercept. So this is always point 0, comma b. So x will be 0. We just have to go up or down on the y-axis to see where the line crosses. 3, use the slope of the line to create more points. Remember, that slope is rise over run. So remember, that's going to be the vertical change over the horizontal change. And of course, we'll model that here in a few moments. And last but not least, use a ruler to draw a line that extends through the points, placing an arrow on both ends. Allow me to say, if you don't have a ruler, that's okay. All you really need to do, the important thing from this, is draw a line that extends through the points and make sure that you place an arrow on both ends. That's just a little pizzazz, so to speak. So we're going to go ahead and we're just going to dive right in. Now remember that the equation given to us is going to give us the important information. Now steps 2 and 3 tell us what we need. We need to know what our y-intercept is, and we need to know what our slope is. And remember that slope is represented by the variable m. Y-intercept is the b, because we have that equation, y equals mx plus b. If it helps to write it up here, I will. So as we look at this first example, y is equal to negative x plus 5. Now remember, if we move from left to right, we know that the m is always in front of the x. So when I see this, I see negative x. I don't see a number there, so what number is there? Well, remember that that's going to be a 1. So really, this is negative 1x. And that means that my slope is negative 1. Now, slope most often is written as a fraction, right? So I'm going to want to write this as a fraction. And I can do that easily just by putting a 1 under it. This is turning a whole number into a fraction, because any whole number divided by 1 just gives you that whole number back. Now, if I look for the y-intercept, is, of course, b. And that's going to be the constant number, which in this case is 5. So now I have my y-intercept, I have my slope, pulled it out from the line. Now I just need to put this stuff onto the graph. So since the equation was already in slope-intercept form, we can move on to graphing the y-intercept. And the y-intercept being 5 means I go up from the origin, or the point 0, 0, I go up 5. 1, 2, 3, 4, 5. Double check me on that. 1, 2, 3, 4, 5. Good. I'm in the right spot. So we graph the y-intercept first. There it is. Now we need to graph the slope. Now I know you're thinking to yourself, how do you graph slope? Because so far we've talked about kind of like the vertical change over the horizontal change. We've found it, but how do we plot it? Well, the idea is very simple. We use that very essence, the rise over the run, to actually find another point. We use slope to find another point on the line. Now this slope here, -1 over +1, is the same as saying down 1, right 1. I go down 1, then I go right 1. And this is the pattern that I follow. Remember, the number that's in your numerator is the rise. That tells you how far up or down. So -1, down 1. And the run is always to the right, so it's always positive. And so I can just keep on finding new points on my line using that slope. So down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Perfect. So at this point in time, we've found a lot more points, really. And from here, all we need to do is use a ruler, but you don't really need to, draw a line through the points. We're going to draw our line through these points, and I'm going to be as straight as I can be. I might not have a ruler, but that's okay. Just draw, if you don't have a ruler, just draw the straightest line that you can. And don't forget to put the arrows on both ends. I don't know why I'm going to be picky about that, but I am. Remember that this is a line that goes on forever. All right? So maybe you have it, maybe you don't have it. So let's do number 2. We're going to do number 2 and number 3 here. And again, making sure that you pull out the slope and the y-intercept. The slope is -3 because it's right in front of the x. But that's a whole number. I want a fraction. So -3 over 1 it is. Then for the b, notice that that is -1. Normally we'd have a plus, so what this tells us is our y-intercept is a -1. So, just like we did, start out at the origin, 0, 0, and I'm going to go down 1. That's what my y-intercept is, -1. And then from there, again, I'm going to use slope to find more points. And this slope is -3 over +1. -3 is in the top, so that's my rise. That means in this case, I'm going down 3. So 1, 2, 3. Down 3. And the run is a +1, so I go right 1. So there's my next point. Now here's a funny little trick. If you have a ruler, this part is a lot easier. But if you're like me and I don't have a ruler, this isn't very helpful because trying to draw a straight line through 2 points with that much graph space is not very easy. So what can be very helpful to us is having more points. But I can't go any further to the right because I'd run off the graph. It is possible to find points by working backwards. And it's simple enough. Here's what you do. If you want to find points by working backwards, by going to the left, you just have to flip the sign on the numerator and on the denominator. So that negative turns positive, and this +1 turns into a -1. And this is a way of like walking backwards, so to speak. So now what this tells me is the +3 means I'm going to go up 3. So 1, 2, 3. The -1 tells me that I am going to go left 1. So there's that point. And by working backwards, we can actually find 2 more points this way. So I've already found 1. Let's go ahead and follow this backward slope one more time. So 1, 2, 3 up, 1 to the left. Look at that. Now I have 4 points, and that's going to be a lot easier to draw a straight line through for the most part. I'd actually like to attempt that again. Most people would probably stop there, just be like, that's a good line. I'm a little bit more picky. But still, even that's not perfectly straight, but we get the general idea. We get where the points are, and we can figure out slope, and we can figure out y-intercept. So we're good. Do the same thing for number 3. I'm not even actually going to pull them off this time. I'm just going to underline them. Hey, that's in front of x. That's the slope. This number 2 over here is a constant, so that must be the y-intercept. So let's go ahead and model this. So always plug the y-intercept first. That's an easy point. That's at a positive 2, so that's 2 spaces above the origin at 0, 0. Now I need to use the slope to find the next point. 2 is my rise. That means I go up 2. And 5 is the run. That means I go right 5. 1, 2, 3, 4, 5. So there's a point right there. Now again, drawing a line through 2 points with that much graph space is going to be kind of tricky. So what I'm going to do now is I'm going to flip the script and change the sign on both of those numerator and the denominator. Now I know a negative divided by a negative usually comes out to be a positive, but let's leave it like it is so that way we can work backwards. All this is telling us is that we're going in the opposite directions. So instead of going up 2, I'm now going down 2. Instead of going right 5, I'm now going left 5. So 1, 2, 3, 4, 5 to the left. Puts me right there. If at any point in time you get confused about this working backwards, then maybe just focus on the slope moving to the right and just find whatever straight edge you can. So now that I have 3 points that span most of the graph, I'm going to try to draw the straightest line that I possibly can. And that actually did not turn out to be too bad. Drawing my arrows, there we go. And so if you look at most of these examples, they will follow similarly. I could do number 4 real quick for you. Look at this. So keeping an idea, actually I want to change colors too. Negative 1/4 is M, 3 is B. If I do this, plot the 3 because that's the y-intercept. Then my slope is negative 1 over 4. That's really what it means, negative 1 over 4. It's negative 1 over a positive 4, which means I'm going down 1, right 4. 1, 2, 3, 4. But once again, I'm stuck. And so to get, to work backwards, to work backwards from this, remember that I can flip the signs on my numerator and denominator, and this will tell me where I need to go. So walking backwards from negative 1 over 4 is positive 1 over negative 4, which means I go up 1 and to the left 4. 1, 2, 3, 4. Something of a perfectionist, I hate to say it. Then I'm going to go ahead, draw my line, straight as can be. So really for these, all you have to do is acknowledge the slope and the y-intercept, graph the y-intercept, then use slope to find more points. Now as I look down here, 5 and 6 are just like the first 4. You just have to find the slope and the y-intercept. Now number 7 is a little bit different, and then 8 and 9 are also different. So I'm going to look at 7 and 8 to really give you a better idea of what we're doing. So if I tried to pull off the y equals mx plus b, if I wanted to find slope and the y-intercept, slope is easy. Remember, slope is always in front of the x. So slope in this case is negative 4. And if I wanted to write that as a fraction, it'd be negative 4 over 1. Now, on the other hand, my y-intercept is not there. I don't see a plus some number. It's important to know that when we have nothing there, we use the numerical value for nothing, which is 0. If there's nothing written there, then our y-intercept is actually 0. And this is simple enough to draw because when our y-intercept is 0, we're just drawing a point at the origin itself because we didn't go up and we didn't go down. We were lazy. This line goes nowhere. It just stays at the origin. Simple enough. Then using slope like we have been, we use it rise over run. Negative 4 over positive 1 means I'm going to go down 4 because negative 4 is my vertical change. Down 4, 1, 2, 3, 4. And then I'm going to go right 1. And then simple enough, we can easily work backwards. And by flipping the signs, I know that I can go up 4, 1, 2, 3, 4, left 1. And that will find me a backwards point, so to speak. So then, now that I have 3 points that span most of the graph, I can draw my line with ease. And there we go. Now the honorable mention that is number 8 is simply this. Normally our equations look like y equals mx plus b, right? Now this one looks a little bit different because we see the x here, and with it the 5. Before that, we have the negative 3. I'm just trying to show you this because the order is simply backwards. It doesn't mean that negative 3 is going to be your m and positive 5 is your b. That's not how this works. The constant, or the number without a variable, is always going to be your y-intercept. So even if negative 3 comes before that 5x, it's going to be my y-intercept because it is the constant. It's something that doesn't change. Now on the other hand, when you have this 5x here, that's still going to be your mx. For the purpose of your m, or your slope, is what describes the variable x. So m always goes with x, like we've said before. And so if I go to do this, remember that we plot the y-intercept first, which in this case will be negative 3. So I'm going to start at the origin and go down. 1, 2, 3. There's where our initial point is. And now our slope is the number in front of x, so it is positive 5. That means that slope is 5 over 1. That means I need to go up 5, right 1. So 1, 2, 3, 4, 5, right 1. So there's a point. And I know that if I try to do this next point, I'm going to end up just off of the graph, but that's okay. We're going to try it anyway. 1, 2, 3, 4, estimate of 5, go over 1. And I'm going to draw the straightest line that I possibly can. So there's our graphs. If you have any questions, you know what to do. Otherwise, I hope you all have a fantastic day. In case you were wondering, this message was brought to you by the pun of the day. A crazy wife says to her husband that moose are falling from the sky. The husband says, it's reindeer. Have a great day.